Let's have a look at scale. This is a very popular exam question, and rest assured that you would have it most probably in both papers. So one of the first questions we need to understand is to write a bar scale in the format of 1 to something. Now when we deal with scale, we always want to say that it is centimeters to centimeters, and this is paper to reality. Now what that means is for every centimeter on paper, you have an equivalent measurement in centimeters in reality. When we write the format like this, there are no units because it is a ratio which has the units are the same. It is implied that it is in centimeters. Right, so let's do this first question. Write the bar scale in the format 1, 2. So the first thing you're going to measure using your ruler. And from the ruler measurement, we can see, because this is the paper, because it's measured in centimeters, so we have paper to reality. It is going to be 5 centimeters. We always set up with our units, and in reality, it is 4 meters. Now remember, we need to get all our units the same. In scale, we want to change the units to centimeters. So what you're going to have to go and fetch is King Henry. King Henry died miserable death called measles. And I want to change from meters to centimeters. So when I go meters to centimeters, I'm multiplying how many bunny hops? Well, there are 2, so I'm going to multiply 2 bunny hops. I put a 1 in front. So I multiply by 100, and now I will get 400 centimeters. 5 centimeters to 400 centimeters. My units are the same. Now I'm going to make sure that I get 1 to something. And how do we do that? Well, if I divide that by 5 centimeters, that will cancel, and I will now have 1 to, what I do to the one side, I do to the other, 5 centimeters. And if I cancel like that, I get a scale of 1 to 80, which means for every 1 centimeter on my book or on the plan or on paper, I have 80 centimeters in reality. Right, as soon as we have a number scale, we're going to use the number scale to calculate certain dimensions. So in this case, I'm going to ask you for the total width of the building, which you would have seen. The total width of the building is from the stairs to the outer end of the bathrooms. And remember, width is always smaller than length. So length is always your longest side. This one was 12 meters, and you can see from your plan, which is drawn to scale, that this side is much shorter. Let's go back to our scale. So what you have to do, use the scale. So from the previous question, our scale was 1 to 80. What you are then going to do, that is what we call your fact. So this we are going to revise ratio again. We write down our fact. We then have to set up an equation. So we're going to go to our map to get another measurement, and you're going to use your ruler to measure that width. And if you took your ruler, you would have seen that it was 8 centimeters. Centimeters tells you that it's on paper, so I always have paper to reality, and I have 8 centimeters. And because these implied centimeters to centimeters, which we showed, I want centimeters in reality, and I can always convert to meters afterwards. So I want to find out how many. I'm going to put an X. Make sure they are the same units, which we've just checked. And now we're going to write it in fraction form. So you had to check units. Now we're going to go fraction form. And this is going to be 1 over 80. I now ignore my units. 8 over x. I then, for number 4, I cross multiply. So I take the 1 at the top and I multiply by x at the bottom. So that's going to be x equals, now I'm going to say 80 multiplied by 8. 8 8s are 64, so it's 640. I go back. What did my x equal? So these are going to be centimeters. If you were asked to write it in meters, you would say, once again, you go back to King Henry. Now this time, King Henry died miserable death called measles. I suggest you write that on your exam paper or your question paper before you even start. I'm now going centimeters to meters. I divide, and it's 1, 2 bunny hops. So I'm going to divide by 100. I don't have to do anything to this side because it's just a straightforward conversion. That would be 6,40 or 6,4 meters. So that is how wide your building is. The other one, another one, so now we went from paper to find out the measurement in reality. We're now going the other way around. It says the pathway from the car park to the classroom is 7,5 meters long. What will the length be on the map? So we always start with our fact. So the fact was 1 to 80 equals paper to reality. Meters over here tells you that it is in reality. So I've got 17,5 meters. I want to find out how many centimeters on paper. Right, remember it is implied centimeters to centimeters. So this is the problem. Meters to centimeters, you go and find King Henry and you multiply by 100. So I now have 1 to 80 equals x centimeters to 1,750 centimeters. So my units are the same. I'm now going to cross multiply. Fraction form first. So 1 over 80 equals x over 1,750. So I had to go fraction form first, which would be number 2. Number 3, I cross multiply. I always look for my x. So I'm going to say 80 times x is 80x equals 1 times 1750 will equal 1750. I want to find out what x equals. So I divide both sides by 80, divide by 80. That will cancel, and I've got x equals, and that will give you 21,875. Remember, this is on paper. So we're working with millimeters here, so I would round to 1 millimeter, 1 decimal place. So x, I look at the neighbor, so I'm rounding to 1. I look at the neighbor, 5 or more leaded source, I have to add 1 on there. So it will be 21,9 centimeters, which I can draw on my paper. I can't really draw a fraction of a millimeter. Right, those are the basics. Now we have to get to the interpretation. So what they say to us, is the scale accurate? So what you would have to do in a situation to determine if the scale was accurate, you'd have to do a calculation. So you're going to calculate as if the scale is accurate. So I would use the scale 1 to 80. I would go and measure the wall in centimeters, and then after I've done the whole calculation, I would get to, for example, 6,4 meters, what you're going to then do, you're going to take that and you're going to compare to the diagram. So the scale diagram that you were given. And if they are equal, so if the 6,4 that I've calculated did show that the width of the building on the diagram is 6,4 meters, then you can say, yes, the scale is accurate. If it's not, you are going to say, no, the scale is not accurate. Right, another way of asking this is, it says, show that the scale on the elevation map is not 1 to 80. So it's not saying, is it correct or incorrect? So we just have to prove that it is not 1 to 80. So we go the same route again. So we're going to go paper to reality. And when I go and measure this in my book, I will find that it measures 3,2 centimeters. You have to be accurate to the nearest millimeter. Okay, on this diagram, we can see that that entire length is equal to 4 meters. So what we have to do, we've got to get to 1 to 80 over here. That is what we are trying to prove. So again, what we have to do, meters to centimeters, King Henry died, so I'm going to multiply by 100, and I will get 400 centimeters. I now have 3,2 centimeters equals that. I divide by 3,2 centimeters because that is exactly the same as that, and then I get 1 equals, or now we're going to convert it to, I divide by 3,2, and if I divide that, I'm going to get 125, which I now, again, it's a comparison, so therefore the scale does not equal 1 to 80. These are application type questions, and this is the type of thing you would see in paper 2. Right, for practice on this, I'd like you to go to page 194, exercise 1, and the ones I've selected is number 2, number 7, 9.1, and 12. And then that would help you to see if you actually understand